Okay, this last problem isn't a big one. I thought I'd tell you. I wrote big numbers and little numbers. I didn't actually mean that. What I meant to say was positive numbers and negative numbers. So you might want to fix that. Or no, I guess I did mean this. Here's what I meant by this now that I think about it. Anything that's positive is going to turn into a really big number. And what I mean by it this time is, like if you have 10 squared, you're saying 10 times 10. And so even though 10 seems kind of small, 10 times 10 is a lot bigger. It's 100. And the more of these 10s that you start to multiply, the bigger this number gets. So if this were 10 to the third, this would be 10 times 10, which is 1,000. And 1,000 is even bigger. So you go 10, 100, 1,000, 10,000, and you wind up with a lot of just big numbers. The more 10s you add. So then just the opposite, little numbers for anything that's negative. And the reason for that is that you're taking away tens, or you're dividing by 10, meaning you're taking away digits. So if you divide by 10, let's say you have 10, you divide by 10, you go to 1. If you have 1, you divide by 10, that's going to get you to 0.1, and then 0.01. These just get smaller and smaller and smaller. So in one of your problems here, it was number 22. It says express in scientific notation. Notice your number is really big. What we're going to wind up doing is just moving our decimal place. So there's only 1 to the left of the decimal place. So this would turn into 4.375. You'll notice I dropped these zeros. It's because they're not really important here. And what you're going to say is, if I move my decimal place there, how many of these numbers did I take away? And there's 3 zeros, then there's the 7, the 5, and the 3, which means 6 of these digits is what I did to move that decimal to the left. So this is going to turn into 4.375 times 10 to the 6th. So when you look at this, it looks like a small number because you're saying 4.3, but really we're saying times 10 6 times, which we know is a really big number. And if you look at this, it is a really large number. It's 4,357,000. Then if you look, they're saying go the other way, express in scientific notation, or I'm sorry, standard notation, which means just go back to a normal number. You'll say, is this positive or negative? Looks like it's a positive 2, so we're saying times 10 2 times. So we want this number to get bigger than 5.2, which means you're just going to move your decimal 2 places to the right to make it a bigger number, and that'll make it 523.5. Now this isn't on your test, but I wanted to show you the counter to what I just showed you. Let's say you have 6.34 times 10 to the negative 5th. That means you want this number to get really small. Right now you're at 6.34, so you're going to have to make this number smaller than 6, which means you're going to move your decimal 5 times to the left. And so this will turn into 0.00000634. Tinier than 6. Again, if you go the other direction and they say turn it into, so that was standard notation. This is converting back to scientific notation, 0.00056. If we want this decimal to be in between the 5 and the 6, normal numbers, this will be 5.6. And then you'll say times 10 to the negative 4th, which tells you this has got to be a really tiny number. And it's just how many places you move the decimal, 1, 2, 3, and then 4 to get to 5.6. So that's all you're doing for scientific notation.